go over the like laws of adding and like multiplying in series again?
You mean like the sigma notation?
Yeah, yeah.
Yeah. So in that case, actually, I need my mouse here now. It's just there's you just separate it out. Like in the case of numbers one and two, if you have a minus, you could totally break up as separate sigma notation things, right? That'll be a minus there for R, and another minus. And of course, you have R equals 13 to 30 and so forth. So yeah. I mean, so if it's a plus or minus in between terms, you can do that. Times divide, you can't, or exponents, you can't. Or if
Okay.
it's a scalar, like if you had, two times all that junk, then you could put two on the outside. You could do that. But yeah, but nothing for times or divide, you can't.
Okay, thank you.
Yeah.
Mr. E,
Oh, good.
do you want us to know what is it called? Summation of summation stuff? Because that was in this packet.
Yeah, that might be good. Let's do it. Let's talk about it. It's a little
Okay.
tricky. It was like 20 something. Tell me what number it was. I don't remember.
I'm actually getting my packet right now, so I'm not quite sure.
Hold on. This one?
Yeah.
Okay. So here's what you have to remember. First of all, think of like PEMDAS, right? So the inside is this one. So you want to start with that one. And n is not, n's considered a constant. That's the tricky thing. N's considered a constant here. So you could think of it like this, 1 over 3 to the m times 3 to the n, because that's true, right? You could decompose the powers that way. And that's a constant, so you could actually push it out. So really just looking at this. And that's a geometric sequence that's infinite that will converge because your ratio is between -1 and 1. So the first term, of course, is 1. So you can't focus on this, right? First term's 1, common ratio is 1/3. So it's 1 over 2/3, which is 3/2. So what's 1 over 3 to the n times 3/2? Okay, now you're doing sigma notation. I'll change colors for a bit of contrast. You're doing sigma notation, n equals 0, infinity of 3/2 is your constant, and 1 over 3 to the n power. And same thing, obviously, right? Like the first term is 1. Um, the second, then the common ratio is 1/3. So you're doing 1 over 1 minus 1/3. 3/2. So 3/2 times 3/2 is 9/4. There you go. Just 9/4.
Mystery, if I could like ask one
Mhm.
quick thing. I just want to understand like the format of the test, like how many questions and like what types of questions will be on it.
Um, well, it's going to be, um, I'm still actually making some edits. So, I still have to work it out. That's a problem. I haven't worked it out yet. So I'm maybe between 6 or 7 questions. Um, 2 questions I feel will be pretty straightforward. Like you'll know what to do. Um, 2 questions where it won't be quite as straightforward, like the one we just did. And then two that's kind of in between. Like you kind of know what to do, but this will be a bit labor intensive. Like this one, like you had to kind of think critically, like, oh yeah, n's a constant, so I can't be working, I have to be mindful about that. But like something like 1 and 2, I think were pretty easy. So I don't think those are that hard. Um, 3, I think you guys know what to do. It's just a bit labor intensive. So it's kind of 2 questions like that. So yeah, that'll be the format of the test. I'm not gonna make it so incredibly straightforward, like, oh, here's like, a geometric series, find me the sum. Like that's just too easy for you guys. I really need to kind of push you guys a bit more. Duke, go ahead. What's the question? And then Catherine, I'll get to you after that. So Duke, go ahead.
Are we gonna have anything about recurring sequences or annuity for this? Because we haven't really covered that in a while.
Recursive. There could be something recursive. Yeah. We could look at that. Annuities. I mean, if it's clear that it's you're dealing with a geometric sum. I mean, then you just apply it. It's just like a word problem. I would tell you that something's geometric. Um, so, but we could look at that if you guys want. I could dig up some stuff. Catherine, go ahead.
Um, I have like two questions.
Sure.
So like you're looking at common difference and common ratio. Can they ever be like zero? Because like a lot of times you're like when you're solving, you just like a lot of times we just like picked the one that was like, non-zero. Can we just like when you're like down to quadratic, just like divide by like D or something, because you can say it's like not zero.
Well, yeah. I mean, the thing is that you're not going to have a common difference of zero because then it's not really what's the whole point of asking that question. Or it's the same thing with the common ratio of zero. So that's just not going to happen. Um,
Okay.
yeah. So I wouldn't worry about that.
Also, like, I like couldn't like understand question 30.
Okay.
It might have like some like
Uh,
integrals, so like
Well,
I don't
so 30, I think that might have involved calculus, which means I can't ask it as that question. I think that might have been it.
okay.
Um,
So like I don't
hold
have
on.
to worry about that if it has like this in it, right?
Wait, hold on. No, I was thinking something else. Oh no, you can't integrate. Yeah, forget about that. That's crazy. No, that won't be on test.
Okay.
There was one that involved derivatives also. I don't remember which one that was. Eh. That might be like, hold on. I think Kate asked that question. Let's see here. Oh, that was integrals. But there's another one also. I don't remember which one it was. Um, well, before I have you guys try some problems, any other questions on sorry, Arya, go ahead.
I have a question. So in question 19,
Mhm.
we like one of the first steps that we did was we turned 1/n with like a sigma thing. Yeah, I'll just wait for you to get there.
Yeah, okay.
But actually, sorry, it was 11.
Okay. Yes.
So we turned that first part, the 1/n with the sigma thing,
Yeah.
into, but never mind, I just figured it out.
Okay. Yeah, I mean, remember, I foiled xr plus 1 squared, and then I saw that, oh, the summation of xr is 2n, and summation of 1, I know what to do with that. That's just going to be n. Um,
Yeah.
so and because you have 2xr, so it becomes 4n plus n is 5n. And then I kind of clean up this radical where I square both sides. And then I know the summation of xr is 4n. So I just kind of when I worked it all out, I wind up getting 8n, I believe, for xr squared. And so yeah, got it to work. Um,
Would you mind working
the,
through number 32?
32, sure. Okay. Yeah, that's very similar to what we just saw for 29, I think. Because remember you're starting with n, so m's considered, sorry, you're starting with m and you're going to n terms, but you're starting with m, right? Because that's the variable you're looking at. So you need to n's a constant. So you can think of as 1 over 2 to the n. Um, push it on the outside. because we know that 1 over 2 to the n times 1 over 2 to the n, you could just consolidate as 1 over 2 to the n plus n. That's a constant, so m equals 0. And so in this case, it's not an infinite series. So remember, it's a1, 1, and I'll give you guys all the formulas, by the way. Don't worry about that. So the ratio knows 1/2. The initial condition is 0. Sorry, it's 1. So 1, and then 1 minus 1/2 raised to the n power. Because that's the number of terms we'll have. Over 1 minus half, which is negative, which is half. Flip it, you get 2. So it's 2. And if you clean that up, you can distribute. You have 2 minus 2 times half raised to the n power. That's 2 to the 1. You could flip it. Not sure that helps. But then you multiply by 1 over 2 to the n. And you want to sum that. So you have 1 over 2 to the n. That's 2 to the 1. 2 to the 1 minus n. So you can think it's 2 to the negative n. Distribute it, you should have 2 to the 1 minus n minus, yeah, add again. Okay. And then you do the summation of that. And you could break it up as well. N equals 0 to infinity. So when we could think of it, that's 2 over 2 to the n, right? And you can push the 2 off to the side. So I'm running out of space here. Oh boy. Let's see. Yeah, so then I could push the 2 off to the side. That's 1 over 2 to the n. Again, n equals 0 to infinity. And then this one, same thing. But it'll be 1 over 4 to the n, using 2 squared. The first term here is 1 over 1 minus half. So it's 2 times 1 over half, which actually becomes 4, I think. If I'm not mistaken. Then here, and you're subtracting. Okay, that's good. Okay, I was getting a little worried there. I was like, wait, did I overshoot it? And then that's 2 times 1. You plug in 0 for n, you get 1. 1 minus a fourth. 2 times 1 over 3/4, which would be 8/3. So yeah, 4 I know is 12/3. Shoot, I'm not getting the answer now because 12/3 minus 8/3 is 4/3. And I say the answer is 8/3.
Mr. E,
Yeah, go ahead.
when you did the sum of the like finite series, you did it a times 1 to the r to the n, or 1 minus r to the n, but the
Right.
key has it as 1 minus r to the n plus 1. Do you know why that is?
That's a great question. I don't know. Because it should be 1 minus r to the n. Yeah, because let me look at the ant. It looks like I'm pretty close. I don't know. Yeah, there's a 4 there, so I got that part right. That's 4/3. Let's see. Just because they're starting at n equals 0. Maybe that's why. Yeah, because everything else, I did everything else correctly. Hmm. Yeah, I don't know. Yeah, because you're trying to find the sum. Starting with n equals or m equals 0. That's your first term. Um, yeah, you have 1 over 2 to the end, right? The first term's 1 ratio. Actually, I think I do know why, because you don't have n terms. Now I get it. I messed up. You do have n plus 1 terms because the first one is n equals. I should have saw that. That was tricky. Yeah, because you have n equals 0 as your first term, then 1, then dot dot dot, then n. So that's n terms, and that's another term. So yeah, now I see why it's n plus 1. Yeah, I assume there are n terms. There's not. There's actually n plus 1 terms. Yeah, darn it. I'm not gonna do it over again. So um
Wait, I'm sorry. Can you explain that one more time? Why is there n plus
because
one?
when we summed up the first sigma notation, I assumed there are n terms. It was actually n plus 1 terms. That's because you start with m equals 0, right? But then you go to m equals n. So
Mhm.
what are the terms?
Really
M equals 0, m equals 1, m equals 2,
Yeah.
until you get m equals n.
Hmm.
From 1 to n, that's n terms.
Right.
And then there's also that one as well.
Oh, and when you start at 0, okay.
And that's why it's n plus 1 for the total number of terms. Yeah. That's where I messed up.
Hmm.
Shoot, that really stinks. I'm not gonna do it over again, but you get the point. What you gotta do, um, where you treat the m and n as if you have to see what the variable of interest is when you're working through it, and whatever other variables you those are treated as constants, and then you just kind of just go through the motions to find the sum. If it's geometric, obviously, and infinite, then you deal with that. I was really close, but all right. That was sneaky. Okay, any other ones here before I have you guys try some practice problems?
I have one more question.
Sure, go ahead.
It's on 33.
Mhm.
They when they're reducing it, they go from r equals 1 to r equals 0 with the sigma. And I'm unsure how they did that.
Let's see here.
It's the first line of the solution.
Let me pull up the solution. So let me understand the problem first. Okay. Okay, so L equals that sum. Okay, let S be the sum there. Okay, fine. Do you understand this part right here? Does that make sense?
Yes, it's up until they go from r
Mhm.
equals 1 to r equals 0.
Okay. Well, they're adding an extra term. So you're replacing R with R plus 1. That's why. Because they have R plus 1 terms. So okay, if you R equals 1 to infinity, but if you go R equals, because you want the same impact, right? So if you plug 1 in, see how that's 0 factorial? that's 1 squared. So if you go r equals 0, you want it to have the same impact. So you want a 0 there, and you want that to be a 1. So that's the reason why.
Got it. That makes sense.
Yeah. Yeah, those are kind of sneaky things. Yeah, just very, very sneaky. So, all right. Okay. Again, before I have you guys try some practice problems, any other questions here? Nope. Okay. So let's do this. So this is the link I put in Schoology. Just trying to see which ones look good. Um, Give me a sec. Uh, yeah, let's try that one. Let's try 6, 6. Say you guys take to that one. Here we go. So it's a geometric sequence. So you multiply by actually, what is a what is a common ratio? Does anyone know?
Is it like 3
Cube
or like
root.
1/3?
It's 1/3. Good. So you use your log properties, power property, right? It's 1/3. Good. Okay. And for B, for the sigma notation, it's pretty clear that we're doing this in terms of K. So ln x becomes a constant. Then we know someone feels like they have an answer for K. I'm sorry, for X. That's what I meant to say. Yeah. Trying to do it in my head here. Let me know if someone's got an answer for X.
I got like E².
Yeah, it's E squared. Yeah. I didn't get that initially, so hold on. I'm just trying to still figure this out. So the summation would be 1 minus those 3/2 9. The 27 will cancel. Let me work it out because I'm gonna drive myself nuts if I do this in my head. Yeah, so again, so that's 3 to the 3 or 3 to the k. K equals 1, infinity. Oh yeah, I know I did wrong now. I get it. Okay. Um, and that's ln x. I assumed that k was 0 initially. Wait, what? I should have used my other that's weird. Okay, I should have used my personal account, but okay. I think we'll be okay still. Like always, just restart the call. Equals 27. 3 to 3 is 27, right? So you push that out. And that's 1/3 raised to the k power. Equals 27. 27s will cancel. Natural log of x. If I plug in 1 for k, I get 1/3. It's a infinite geometric sum. 1 minus 1/3, which will be ln x times 1/2 equals 1. ln x equals 2 because you have 1/3 over 2/3 is 1/2, and then x equals e squared. Yeah, yeah. Nice work, Catherine. Thank you. So yeah, I agree. E squared. There you go. And again, if you click on Mark's scheme, like yeah, they give you the answer there. So okay, that's good. That's perfect. That was a good one. I like that one. Let's see here. Mm.
Mr. E,
Yeah, go ahead.
can I ask a question about a problem back in the original packet?
Yeah, just give me a second. I'm just trying to find a good one here. I like this one here. I think 6-4 is a good one. Again, if you have the link, just it's in Schoology. You go and try 6-4 while Duke asks this question about the old pack. So you're talking about this packet, Duke?
Yeah, number
Yeah.
17.
17, okay.
It's like not the whole problem. I just like one quick question.
Yeah, go ahead.
So for this one, it says like the left side converges, and so I basically simplified the left side into like 2 to the
But
x.
remember, there was a typo there. That should have been 2 to the r power.
Oh, but I just solved it with that and it worked, I think. Like
Maybe I
with
think
the
maybe I think with a different question. Hold on. It was the previous one. No, yeah, because the way they had it set up here was 2 to the r power.
2 to the r.
Yeah, as the index of the radical. That's
Oh, I think you just have to like work around it to get to that point.
what do you mean?
Oh, 2 to the r, yeah. Wait. I think it still works out if you leave it as 2 to the r. You can like it still works out fine.
2r, you mean?
Yeah, this one, the way they did it is like to r equals 1. I don't know why it says it differently, but like they follow the same method as if it was 2 to the r instead of, or 2r instead of x.
Okay, I'm not sure then.
But either way, so if you look at like the equation at the top, the left side of it, you can kind of like turn that into like 2 to the x over 2 times 2 to the x over 4 times 2 to the x over 6, like continuous.
Sure.
And it says that it converges. And so like logically I see that it's like half and then it's half of whatever's left,
Right,
which means
right.
0 and 1, and
Right.
etc. And it keeps going. But I don't know how to prove mathematically that it's going to converge at x equals 1. Or sorry, yeah, just one whole x. But like I know that because I can see that that's what's happening and I see the pattern, but I don't know how to prove that.
Well, I mean, hold on. Make sure I understand this correctly.
Oh, they like log it?
So it's one
Okay.
half,
How do you prove?
1/4. Oh, actually, no. Maybe this is done correctly. Wait, those are x's. Sorry, it's x's. No, still. Well, hold on. X is the one. Still doesn't make sense.
I think it makes sense. Which part?
No, the second and third steps.
Second and third.
Yeah, because an R is 3.
They follow by power. Yeah.
Yeah, it should be 2 to the R power, not 2R.
Yeah, I don't know why they did that, but either way, it'll still end up
Yeah.
like the same dilemma of like, how do
Okay.
you?
Yeah. Then you have log base 2 for both sides. Yeah, because it helps you isolate the exponents. Yeah, because then you use the power property with the exponents to the front.
Yeah, the question I have is like, how
Yeah.
do you prove 1/2 plus 1/4 plus 1/6
Sure,
plus?
sure. Yeah, equals well then yeah, you just factor on x and realize you're dealing with a geometric sum.
Oh, you turn it into a geometric sum.
Yeah.
Okay.
Exactly. Yeah,
Geo-
and then you solve for x after that.
But
That's
if it's
all.
not 2 to the R, it's just actually like 2R, like the original problem, and it's not a geometric
Well,
sum.
if it's 2R, then it would be 1/2, 1/4.
1/6.
Yeah, you're right. That's not. Yeah, that's why it had been 2 to the R power, not 2R. Right.
Okay.
Yeah, that's where they messed up.
But even with like the other one, like let's say it was 1/2, 1/4, 1/6, 1/8.
No, it's not geometric. It's not a geometric sum.
Okay. But it still adds
You
up to
can't.
1 at infinity. Is there a way to prove that?
Um, what that would. Well, I don't even know what kind of sequence that is. I mean, that's just not even. Um, yeah, it's not a power series. Yeah, we have 1/4, 1/2, 1/4, 1/6, 1/8. I mean, it's in arithmetic series. No, that's not arithmetic. Sorry, it
It's
doesn't
not.
make any sense. Yeah, I think to handle that, you'd have to do something called a Taylor and Maclaurin series, and that's calculus BC.
Okay.
So I wouldn't worry about that
Okay.
because remember we're just doing geometric. So yeah, I wouldn't worry about that. But I'm
Okay.
not sure if that would even.
Wait, so we're not gonna get this multiplication like notation thing on the test, right?
What do you mean by multiplication thing?
Like like the arch symbol. We're not gonna get that like multiplication notation, right?
The product operator. Why not? It's a good problem. Though I'm not asking that.
Okay.
Yeah, that was kind of funky. Well, anyway, let's come back to this one here. Anyone have an answer for 64? They're working it out. Okay. Any questions on that one? I mean, final sum should be pretty straightforward, I think. And you can start with 27, and then you know you're adding 9. I trust you guys can write some notation of that. And then find the greatest value of n if you want the sum to still be negative. Any questions? No? Yeah, so again, we know how the pattern works. I believe 31 terms here.